session in the last 1 hour, and I'm already seeing huge talk about AI. So I don't want to bore you with more AI. What I will take you a slightly different angle, and I probably change my presentation based on what I already heard. Because I think there was an IIM session on cloud and AI, and then there was a session from Prasad. So I call myself a practitioner of AI, like the software 2.0, which is building AI products. So I've been building AI products for almost 5 years now, or 5 or 6 years. In fact, 3 of my products got launched in this building here when I was at Google. So one of the first products that I built was Google Smart. If you use Gmail.
Another mic is live.
Oh, there's. Can you guys? Okay. Should I keep it different?
No, I think previous speaker, did he walk away with the mic?
Oh yeah.
You pick it up?
Yeah,
Okay.
sure. But it may be live.
Are you not able to hear me, or these?
No, there's
There's a
another.
double.
There's another mic which is
There might
live.
be a conference room upstairs.
Uh-oh.
No.
No? No, it's just a mic.
Oh, it's on there.
Yeah, keep going.
Okay, keep going. All right.
Got it.
Example was later than we.
Much better. This is good. Now, has the voice gone back? Like,
Yeah.
Awesome. So, one thing, I'll take on more of a practitioner approach. Why it's easy and why it's tough to do AI at scale? Because and then I will deep dive a lot into how AI is being used in finance. That's probably what most interesting. So the problem is I can't put a lot of those things that I work on PowerPoint. So what I'm going to do is make it a lot more question and answer. So if you ask me the right questions, I'm going to so that's how let's do that. Roll it that way. And
Just use the keys. Thanks. Wait.
Give it to AI.
Just use this. Yeah.
okay.
It should work.
So I'll talk about AI and its tech lifecycle because as a practitioner of AI, it's really important to understand where the hype ends and where the reality begins. Because it's extremely difficult to build good end-to-end AI system. There's too much noise. A lot of people doing the talk. There are less than very few multi-billion-dollar AI products in the world, and there is a reason why they are. And people say it's because of lack of talent. It's not, because I think, and I will talk about why that is the case. I'll talk about how, if you're applying AI today, how do you win? How do you actually build product? Because your credibility is on the line. So I'll talk about AI, how to win in AI. And third thing, I will talk about how within the bank, how we are applying AI. And as I said, I'll leave a lot of that for the question and answer at the end, and some of the challenges that we face. So I always begin with this quiz because it starts describing to you why building a working AI system with a lot of small error rate is very difficult. So take this, and this is in the domain of natural language processing or natural language understanding, and same applies, as Prasad said, in the other domains. In vision domain, image understanding domain, speech understanding, and so on and so forth. But really, this NLP is one of the, still a difficult problem to crack. So if you think about it, Katrina took Jennifer's lunch money, she ran away very quickly. Who is she? I think most of us here can figure out who she is. Till one of the products we launched last year at Google, 1.5 years back, most of the NLP systems will get this wrong. And this is the cutting edge. And only recently that this is to a point, depending on how you say he, she, understanding, most of the AI systems still get this wrong. Second, Katrina took Jennifer's lunch money. She ran away to the principal's office to complain. Most of us will know she, in this case, who she is. So it's tough to, I will probably go walk there. So as I said, in the first case, Katrina, most of us guess Katrina. Humans is very easy, and the reason is described in this slide. But the first thing you do is you tokenize every word. This is how an NLP system works. So again, I'm simplifying a lot. So this is pretty much state of the art now. You can pull extremely complex sentences. Tokenization is a solved problem. She is a pronoun, which is again state of the art. Most of these machines today can identify that she is a pronoun better than any humans do. Katrina and Jennifer are people as opposed to hurricanes. That is another problem. Like if you lived in the East Coast, you probably know these two things. That's the first thing that comes to a lot of people's mind. But here they are referring to a person, not a hurricane. This whole problem is called entity resolution. The best in class NLP systems. Some of them are at Google. There are quite a few companies that are doing in this space. The state of the art, still not as good as humans. So, and then I think I'm describing to you what it takes to understand a simple sentence as these two, and where the systems, AI systems are today. So that's the sort of flow. So entity resolution, unless you have a very powerful knowledge graph or model of the world and the background, it's very difficult to understand. And I think Prasad mentioned the context matters for entity resolution, and understanding of the context is very tough unless you have a very huge amount of world knowledge, model knowledge. You have a ability to model the world. So I think it goes on and on. So in the other sentence, when you are reading that sentence, you have a mental model in you. And the mental model was created from the day you were born. The day mother tells the child about, hey, this is how, this is a car, this is a dog truck, they are in this world. The model is being built. Most of the AI systems do not have a very good understanding of the model. They don't do a good job of modeling the context to which they are playing. So as a result, a lot of the NLP systems, and just beyond NLP domain, an AI system fail because they have a bad understanding of the context. So that's, which is where, and how do you create very sophisticated models of the world, is where deep learning doesn't help, which is one of the, I think, I'm throwing so words, assuming you know what deep learning is, because I'm assuming you've gone through some, but if not, a lot of the existing technology that has built over the last 3 to 4 years, or have been mainstream in the last 4 or 5 years, really don't help. And that's the reason you will see AI systems still falling short. And I will start with this, because it's always important, and again, going back to understanding the hype from reality, to this came from a very good friend who's a VP at Google, Jay Gagnick. He's probably one of the biggest, smartest guy I know in vision. He basically uses this as to draw in the 200 history of the development of the technology called photography, all the way from the left, which was the very first photograph taken using a chemical etching process, all the way to today, which is the best in class. Our colleagues will say Pixel from Google, but some might say iPhone from X, iPhone X model. From all the way, that's 200 years, almost 200 years. And just to give you how powerful this technology, 1826, first photograph, 1835, the first aerial photo or visual, like a city landscape photo, 39, the first selfie. If you think about it, that guy is taking a photo of himself in front of 1847, in fact, is the history behind that photo. This is where people say the birth of journalism, modern journalism started. It was somebody taking a photograph of a man getting arrested. And this is where the best, easiest photo for journalism at that time was who got arrested, who went to jail, and so on and so forth. 1860, first aerial photo, 61, first color photo. This is still 2 centuries back. 78, first motion, 1857, 1957, first digital, and today. So if you have to take a guess, based on all the hype you've heard, where do you think AI is today? Like what year is AI? Like apply the same 200 years of development of tech, around 1835. 1835, how many people think it's beyond 1860?
It's at least 50 years it's been in progress.
1860. So I'll quickly go. And the answer is we are in the selfie mode. Oh, sorry. This is, I'll cut through this chase. This is where we are. Very, very, very early in the, again, people will differ. Some people might say we are 1847. Some people might say, but that's still, almost nobody will say we are in even this last century. And that is pretty powerful. And somebody who's building products in this space, you have to be very careful about it. So what makes an AI system work? This is directionally right. You can debate every one of this to length, but this is how most of the most powerful AI systems are being built today. And again, somebody who's built 6 different AI products, even this sometimes doesn't work. So, so it still requires a massive amount of data. To give you the most powerful example I gave you was, how many have seen the Google demo where last year at I/O, where a bot is calling a reservation, making a reservation? Almost all of you. You know how much money Google spent on this? I cannot tell that. On that demo, it's probably the most expensive demo in human history. But I'll tell you, at one time, so I was very fortunate to be part of that team building that product for the last 2 years, mostly on the NLP side. And it came from, there's amazing history behind that demo, and you should, if I had time, I'll talk about that. But at one time, there were 1,000 call center operators for almost 4 months, making around, I think, 1,000 calls every day to reservation system, calling hair salons, restaurants, and their calls were being recorded. And we generated around, again, amazing amount of data. Imagine that amount of expense. That was used to train the model to understand, bring some human element to this. That's the power. That is the kind of data that was required. So huge amount of data stored there. And the reason you need that is, if you notice that demo, because I'll talk about that demo, I don't have the video to play with it. It takes pause, it understands, it increases the tone, reduces the tone, makes you sound human, is a lot of work. And what are the 5 things to say? It interjects when somebody says, hey, the slot is not available. So it says, okay. Doesn't answer, okay, can you give me a second slot? Because computers can, if a slot is not available for reservation, they can move to a different slot very quickly. That can you give me the next slot? But if you don't add a pause, you don't sound human. That is something that you have to learn. That is something you cannot program into a system. Anyway, so that was one big part. You literally, once we recorded that data, and this happens even in a bank today. We have, as I came to JP Morgan, one of the biggest area of investment I did was to hire people for being first and two. We have now a huge team in India, which is just tagging data, bank data for us. That's the second part. You have to have a huge ability to accurately tag. So this particular thing is, this is a cat, this is a dog in image, this sentence means this in this language, so on and so forth. It's still single domain. So when I say single domain is, you can take a vision problem, and I think Prasad, if he's around, he will, most of his problems that he described are essentially video understanding. Why not use video understanding combined with ability to understand what's going on, sound, combine that with other sources of sensory data. That kind of very convoluted multi-domain models and optimizing on that is still a very difficult problem. So most of the successes in AI that have occurred are in language translation, which is a very single domain language understanding problem. Ability to have a good question and answer through bots, another natural language problem. But then combining voice with natural language, which is, let's take the example of customer service. Understanding through voice and in voice converting and having a voice chat bot is still a very difficult problem. Computation power is still to do all this and train the model, and I'll give you a sense of what it is. And you still require a lot of expertise, which I don't believe this will be the case in few years from now. And the best example I give is when I was starting my company in 2012, I remember 2011, it used to take me $500,000 to build a pretty good high quality mobile app, iPhone app. Plus minus with designers, developers, everything. Same quality, much quality, higher quality app I can build today, less than $5,000. Huge deflation. Why? Because a lot of sophisticated tools have come on board. Same thing is going to happen in AI. Right now it takes a good AI product with ability to self-learn, with ability to improve over code, with ability to have tagging which tags mistakes the AI system makes and so on and so forth. It's usually in the order of $1 to $2 million. And I did that exercise at JP Morgan, and I can't tell you the specific number at JP Morgan, but we are not very far off from that number. So that's $2 million or $1.5 million to build an AI system. Seems it will come down to a few $100 pretty soon. So data, why is data is important? This is because of the Syntup chart. Again, won't bore you with the details. One of the biggest things that happened is deep learning. Almost every other algorithm or technique that was used before, if you throw more data at it after some time, it sort of saturates. With deep learning, a lot of the neural models, that is no longer the case, and you keep on improving the accuracy, and that's the reason if you throw more data at it, you will see a lot more improvement and better quality. So I'll skip to this. Computation power is a huge, like this is again, these statistics we use. There was a whole movie around Apollo and how Apollo system, the compute power that was needed. A simple Google search today, a one Google search consumes more power than all of the power used in Apollo. So that's the, another example I give is this. So again, there's a lot of details here. The most best, like CNN model, where do you see CNN? AlexNet probably is what I will say, one of the best image understanding models. Use that, these are different models and different techniques, and this is the amount of compute needed. The best, Google Translate, which was one of the products that I had, was that to build a Google Translate system, the amount of compute power you needed is around less than 100 petaflops. The newer models, the AlphaGo, if you've heard about it, require that much compute power to train the model, train the system. And then Dota 5, which is the recently OpenAI released a video, so AI system that can beat humans in the game of Doom, I think. So that requires that much compute power. Big point of all of this is unless you have huge compute power, it's very difficult to build very sophisticated AI system. And that's the reason a lot of the greatest AI work right now, at least cutting edge work, is being done at companies which have throwaway compute power. Google, Facebook, Amazon, so on and so forth. And that's one of the first thing we did when I came to JP Morgan was, banks are excruciatingly slow in adoption of public cloud. And Jamie Dimon recently released in a shareholder letter that we are going all in on public cloud. And that was one of the biggest reasons because of AI. So, and of course, having dealt with regulators, and I already had, I think, I've been in front of regulators 4 times describing why public cloud is not a problem with AI banking, and because of this. So unless you have a huge compute power, you cannot be successful in AI today. This is probably too detailed for this audience. Essentially, this says these are like research paper, cutting edge research paper over the years in terms of improving accuracy. Point here was literally it took you 2 or 3 years of one of the brilliant scientists to come out with a 2% improvement in any AI system. That sort of emphasized why you need an AI data scientist who gets paid $1 million to actually do some cutting edge work. But with some of the newer techniques like AutoML, that is going away. So in this case, so one of the, probably it's not in this diagram. So let's take an example of image understanding or ability to classify image, whether it's cat or dog, through ImageNet. Newer techniques doing AutoML, which are completely automated, no training, no data scientists ever involved, get better results than the best results. So as AutoML gets applied in multiple domains, you will see that ability to have hugely sophisticated data scientists kinds of goes away. But you still need a data scientist for the end-to-end design and the systems design, but not for domain specific. And I think that's probably being recognized increasingly. The Turing Award went to this year's Turing Award went to the top 3 guys in AI. And I think that probably will continue for the next few years, but ability to, unless you understand an AI system end to end, it's very if you are a very domain specific specialist in say vision understanding system, your sort of value goes down tremendously in the coming years. So all of this comes with it. We are far away from AGI, because I don't know how many times I've been asked when I came to the bank, are you going to take away my job? Are you going to, should I, as a, like people, traders at bank typically get paid 1 million to 1.5 million. I don't know how many people have come to me and said, are you going to take away my job? I basically said no. Definitely not in any time in the near future. What I would say is that we are, for example, we have a program called Robo Trader, which essentially all it is doing right now is we have an eye tracker. We basically a keystroke sort of monitoring. We monitor everything that the trader does, day in, day out. And we have already generated around 2 years of data on this. This was a program before me, and now we are sort of tagging all those activities. And we already got some amazing results simplifying some of the most basic stuff they do. And more importantly, as I think again, the mistakes they make. So traders make amazing amount of mistakes that they will never accept. But once you start analyzing their data, you will start realizing that, and of course they are not, it's not fun to talk to them about their mistakes. Right? So this is what I'm allowed to talk. But I think I'll quickly finish up. Contact center is a huge area. So I think the way I really classify application of AI, one is operations, which a lot of this that you will see, and also in revenue generating activities. So almost all of these are being actively worked on across the bank, in the industry. So I would, depending on the interest, I will go into this. Contact center, bots have been there for so long. Real innovation there is not in bots. Bots is a commodity now, where innovation is applying voice combined with interactivity, combined with process understanding. That's where the cutting edge of, and this is where one of the products Google launched, Google Contact Center AI, and now almost every other companies in this space is working, is a robotic assisted customer service, where depending on how the conversation is going on. So the product is simple. Phone call comes in, like the typical IVR automation, that is old school. Call comes in, the bot is listening actively what's going on in the conversation. Depending on how the conversation is going, starts suggesting to the customer service agent what should be said to. Very similar to what Google did with Gmail Smart Compose. And once it identify what the workflow was, identifies what are the 5 things the agent should say and what he or she is saying, where the deviations are, and then improving the process over time. So there's a lot of sort of custom work being done beyond what you see. Virtual advisor is another one interesting. We have slides on it, but because I have like 2 minutes, virtual advisor So again, it's not robo-advisor. That is like literally rules-based engine that Wealthfront is selling for $2 billion. That's old school. Robo-advisor is essentially some of the things we are working on. And again, I can talk some of it, not all. Imagine, so most of the people who have wealth advisors, people with more than $5 million net worth, this is the bulk of the business for the bank, you will be surprised how much control they want to have on their investments and how many mistakes they make. The problem is today, almost there's no way to understand or advise the client in terms of mistakes. So for example, we started again recording data, understanding what mistakes were made. People who will classify themselves as risk averse or high risk takers, when they started looking at their trading history, more importantly, tying that data with what the market was saying. For example, December was a highly volatile market. That regime is highly volatile. If you are risk averse, you should not be touching your assets at that time. The people who classify themselves as risk averse are the most active traders in this time. So, but how do you generate that data? How do you generate that insights? Most of the wealth advisors say, I understand my clients. That's complete bullshit. Because they have traditionally understood that over a span of time, but not on a market timing basis, market regime basis. That's the next level of insights that we are generating. And that's just one example. Tax is a huge other area where timely advice based that is relevant to your activities going on in your account, changes in law, and giving that advice to your customer at the right time, at the right place, is a completely different system that no Silicon Valley company or startup can do, because either they don't have the domain understanding or they don't have the data. So that's the reason a lot of that work has to be done. So that's another example. Cash forecasting, some very amazing examples. I'm running out of time. Interesting example I will give you is on trading. So JP Morgan is probably number 2, number 1 bank in terms of cash equities trading. Essentially, these are institutional hedge fund will say, I want to buy $10 million of Apple. And it comes to JP Morgan, executes that trade in the next 5 minutes. If JP Morgan takes that bulk trade of $10 million, executes in the market, it will move the market. What will happen is, because somebody will know, a huge order came, Apple share will spike price will spike for the next 5 minutes, you get screwed on the order, and then the hedge fund guys comes and yells at you. So the way you do that is you break down your $100 million or $10 million order into small pieces, and it's an optimization problem. Then you what pieces to break down, where you place the order, when you place the order and remove the order from the market. It's a very complex thing. So traditionally, again, banks have been hiring quants, and they hire quants for a long time, very smart guys. So they have built huge models. So we applied reinforcement learning, which is essentially, easiest way to understand is the system takes an action, understands what the action causes, what kind of reaction, and then understands the reaction and makes corrective answer. This is the same technique that AlphaGo used to beat the AlphaGo champion. So we applied deep learning, deep RL to this problem. Within 4 months of doing this, we are already beating the best optimization algorithm that the bank had. Having said that, in simulation. So we haven't applied that in real life, because real life is always tough. So again, if we prove that, that's the kind of application we are talking about. So let me see, I'll probably pause there. Risk management is another huge area where reinforcement learning optimization problems are being applied. Understanding contracts is another area. There's a research work we are doing with Stanford here on understanding and converting contract language into computer code, and then understanding violations. So anyway, I'll pause there, open for questions.
So we have 5 minutes.